All right, so now we are going to be talking about OChem. So the intro to OChem, I'm just going to be talking about alkanes, alkenes, alkynes, and how to name them. So alkanes, remember that organic chemistry, this is the study of organic compounds. And organic compounds always have carbon. Now, let's say if we have CH4. Now, carbon a lot of times is paired with hydrogen, okay? And remember that carbon likes to form four bonds. All right, it likes to form four bonds. And I mean, it doesn't have to be four single bonds. It can be like one double bond and then two single bonds. But notice how like the amount of lines I draw for a carbon always adds up to four, right? So carbons like to form four bonds. Now, an alkane is characterized by the fact that this carbon only has single bonds to the other atom. Alkenes, well, there's a double bond, right? You see a double bond here. Alkynes, triple bond. So yeah, that's basically the difference. Remember that alkanes are saturated. Because of the single bond, they are saturated. Saturated, in terms of OChem, basically just means that this carbon is bonded to the maximum amount of kind of other atoms possible, right? Notice how this carbon, because it has a single bond everywhere, it's bonded to four atoms. But if you look at the rest right over here, they're bonded to less than four, right? So they would be considered unsaturated. Alkanes, they're saturated because it's basically the maximum amount of atoms that this carbon can bond with, right? So it's saturated, while alkenes, alkynes, they only bond to two, in this case, or three, other atoms, right? So they are unable to bond with, as many atoms as possible because of the double bond. Let's learn how to name organic compounds. Let's start with naming alkanes. I have three carbons in a row, and I have the rest of them are hydrogens. How do I name this? So your first step is to count the longest carbon chain. Longest carbon chain. So how many carbons do we have here? Well, we have 1, 2, 3, right? This is the longest carbon chain. Now, if you look at your table right over here, notice how if you have 3 carbons in a row, for your longest carbon chain, the prefix is prop. So I'm just going to write prop down. Now, also notice how this is an alkane because all of our bonds are single bonds, right? All of these bonds right over here are single bonds. So what I have to do is, because remember alkanes, right? Literally remember the name, alkane. Alkane ends with a A-N-E, right? Alkane ends with a A-N-E. So what we're going to do is we're going to add an A-N-E at the end. So the name of this organic compound is called propane. This prop comes from the carbons, and this ane comes from the fact that it's alkane. Let's do another example. Let's say if we have something like this, carbon compound. So this is an alkene because it has the double bond. Remember, alkenes, double bonds, alkynes are the ones with triple bond. Now we're still going to use this table, all right? So kind of no matter what, in this first video, we're going to hold on to our table. Notice how there's 5 carbons in a row, right, in a chain, right? So if you can draw a line through these carbons and they still connect, right, then it's one long chain. Let's say if I have a carbon compound that's something like this, where let's say it's like split. So let's say if I have some compound that's like this, where it's a CH3 here, CH3 here. So, okay. Let's say if I have a compound like this, where notice how this carbon chain splits up into 2 sections. So what is the longest carbon chain, right? When it's talking about the number of carbon atoms, it's basically asking us what is the longest carbon chain, all right? So how many carbons in a row are linked together? So you can count 1, 2, 3, 4, and you have to go up 1, 5. But notice how this carbon is disconnected, right? So actually, this compound right over here, the longest carbon chain for this compound would actually be only 5 carbons because this carbon right over here is always going to be isolated. It doesn't matter the way you draw the line, right? Let's say you go from this carbon, 1, 2, 3, 4, and you go down 5. Notice how it's 5 carbons in a row, and there's always one carbon that's isolated. So the longest carbon chain is going to be 5. Remember, it has to be in a row, right? You can't just like hop over like that. Okay. That's just something I want to get out of the way. Now, what you're going to do is after you identified how many carbons we have in a row, so notice how we have 5 carbons in a row, so it's going to be pent. So I'm just going to write pent down. Now I'm going to start naming these carbons from the carbon that's closest to the double bond. So the carbon that is closest to this double bond right over here is going to be this carbon right over here, right? This carbon is closer to this double bond than this carbon right over here, right? When I'm talking about closest to the double bond, I'm talking about like the edge carbons, right? So which of these edge carbons are the closest to this double bond? And the winner is going to be this one. So I'm going to start numbering these carbons from this end. So it's going to be 1, 2, 3, 4, 5. Okay. Now, notice how this double bond is located on carbon 2. So what you're actually going to do is you're going to put a 2 and a dash to indicate that your double bond is on carbon number 2. And because, remember that this is an alkene, you're kind of going to do the same thing you did before. Remember that when we had propane, you got the ane because it's an alkane, right? That's the ending for it. Well, for alkenes, it's the same thing. Because we know that it's an alkene, what you're going to do is you're going to put an ene at the end. And that's the answer. It's 2-pentene. This 2 comes from the fact that this is a double bond located at carbon 2. Pent comes from the fact that there's 5 carbons linked together, and ene comes from the fact that's an alkene, which is why we have the double bond in the first place, right? So yeah, we can do another example. Fun. Let's say if the rest are hydrogens, because I'm a little too lazy to draw all of the hydrogens out. So when I'm drawing out the dashes, just assume that there's a hydrogen at the end of it. Okay. How would you name this one using the knowledge? Well, for starters, how many carbons are there? 6 carbons. So if we look at 6, that's going to be hex, right? 6 is hex. So I'm just going to write hex down. Now remember that this is an alkene because of the double bond. So it's going to be ene. So far we have hexene. Now we have to name these now we have to number these carbons. Remember to number them from the edge carbon that's closest to the double bond. So which of these carbons are closest to the double bond? The winner is this one. So we're going to start naming them. 1, 2, 3, 4, 5, 6. So notice how this double bond is located on carbon 1. So we're just going to put a 1 and a dash. So this is just going to be 1 hexene. And we are done. Now, let's go back to the alkanes. Let's add something called substituents. Let's say if we have except for this carbon right over here. Let's say that this carbon right over here connects to a chlorine atom. So now, how would you name this compound? Well, for starters, you're kind of going to do the same steps as before. Remember to count the longest carbon chain. So there's 7 carbons, meaning that it's hept, right? It's hept. And remember that this is an alkane because it's all single bonds. So it's going to be heptane. Now, what you're going to do is you're kind of going to do the same steps as you did for the alkenes, except you're going to name this thing from the carbon. You're going to start numbering the carbons from the edge carbon that is closest to our substituent. A substituent basically is just something that's not a hydrogen, right? Normally, you see these alkanes, alkynes, all these examples right over here, it's always carbon connected to a hydrogen. But when it's not a hydrogen, you call that a substituent. So this substituent right over here is chlorine, right? And it's closer, this chlorine atom is closer to this carbon, right? To this edge carbon. So we're going to start numbering the carbons from this edge carbon. So this is carbon 1, this is carbon 2, 3, 4, 5, 6, 7. Notice how chlorine is on carbon 2. So we're actually going to put a 2 here, 2 dash. Now we're not done. Chlorine, if you actually have chlorine right over here, it actually has a name for it. You actually have to input chloro in here, right? So notice how I have all of these names right over here. If you have a chlorine substituent, you have to put a chloro to indicate that it's a chlorine atom, right? Because think about it. If I did not have this chloro right over here, well, I wouldn't have enough information from just this 2-heptane to kind of understand what this compound is. Because if I do not have the chloro, well, this could be a fluorine, right? This chlorine right over here could be a fluorine. It could be a bromine atom, right? So we have to be specific. And this chloro basically just tells us that, okay, at carbon number 2, there's a chlorine atom, right? If it was a fluorine atom, well, look at the chart right over here. Instead of chloro, we would just put fluoro. And we're done, right? So you kind of get the idea, right? Different substituents have different sort of names for it, and you got to specify it so you're not confused with other substituents. All right, so now we have 2-chloroheptane. Now, let's say if I put a chlorine atom here. I'm evil, I know. I put another chlorine atom at carbon 4. How do I name this now? Well, what you're actually going to do is actually not much is going to change. Not much. Remember that you're still going to have this chloro and this heptane here because we're using chlorine atoms and it's still 7 carbons and it's still an alkane, right? So we're still going to have that part there. But now, notice how there's a chlorine atom on carbon 2 and on carbon 4. So if you have substituents on 2 different chlorines, or actually it could be the same chlorine, right? If this chlorine atom was located, if both of them were located at carbon 2, you would actually have to put 2, 2 to indicate that they're both on carbon 2. But since it's on carbon 4, I'll just put 2, 4 dash dichloroheptane. Di indicates that there's 2 chlorines. Remember the things you use to name covalent compounds? So you have like di, tri, tetra, and then pretty sure penta, hexa, like something like that, right? So remember those naming things from your covalent compound naming, right? Well, I mean, if you don't know that, then I strongly suggest you review that, because once you review that, everything will start making sense. Trust. All right. So yeah, that's pretty much how you name. If you have multiple substituents, you have to indicate their kind of locations, and you have to indicate that in this case, there's 2 chlorine atoms. All right. Instead of chlorine, I have a bromine on carbon 4. How would this change? And this is going to be like a lot to unpack. Okay, so get ready. Now, when we have 2 of the same substituents, well, you have to use the di, tri, tetra thing I talked to you about the covalent compounds to indicate that there's multiple of the same substituent. But now that there's different substituents, first of all, you have to identify the alphabetical order of it. So notice how bromine is in front of chlorine if you're kind of looking at the alphabet, right? Bromine, B comes before C. So we're actually gonna name the kind of bromine first. So what I mean by that? So first of all, right, bromine is bromo, right? So what I'm actually gonna do here is I'm gonna put a bromo, and because we have a chlorine, remember that chlorine is a chloro, right? Actually, I already have that written down, so I don't need it. All right. Now, where is bromine located? It's located at carbon 4. Where's chlorine located? That's located at carbon 2. And we're done. That's it. We just put this 4-bromo to indicate that, it's a different substituent, right? It's located at carbon 4. Then we have this 2-chloro, right, with all of these dashes, right? And then heptane. And we're done. Notice how this is in alphabetical order, right? I order my substituents in alphabetical order. So, everything is good. So let's do another example. So this is going to be tricky. So let's say if I have this is bute. And remember that this is an alkane because it's all single bonds. So it's going to be butane. All right, good. So far, so good. Now we're going to have to number our carbons from the edge carbon that's nearest to the substituent. However, in this case, you can name it from either side because this carbon right over here has this bromine, this edge carbon has this bromine, so they're closer to they're both close to the substituent, and they both have CLs right next to them, so it's the same thing, right? So let's just say I name it like this. Now remember that B comes before C in the alphabet, so remember that bromo comes before chloro in the alphabet. Bromo, and then you have chloro. Now, bromine, that's located in carbon 1, and it's located in carbon 4. So I'm going to put a 1, 4, dibromo, right? Because there's two bromines, right? So I put a di here to indicate that there's two bromines, and that those two bromines, well, there's one bromine located at carbon 1, another one located at carbon 2. Now I'm going to put a dash, and then chlorines, well, they're located at carbon 2 and 3, so I'll just put a 2, 3 dash dichloro. So sorry if I don't have any space, but so far this right now, this is actually going to be the answer. But we have 1, 4 dibromo to indicate that's at 1 and 4, right? Then we have 2, 3 dash dichloro to indicate that there's 2 chlorines and it's located at carbon 2 and 3, and then butane, but because there's 4, ane because it's a alkane. So notice how everything in the naming thing has a purpose. Okay, so if there's multiple of the same substituent, you use commas. Different substituents, separate them with this dash. Okay, so yeah. Now you might be wondering, remember how I said that alkenes actually have to be prioritized over substituents? So, I mean, what I mean by that is, remember how I said that you have to name the location of your double bond in an alkene, right? So in this case, this right over here is 1-hexene. This one tells you where the double bond is. Well, let's say if we have a compound, let's have a substituent on one edge carbon, and we have a double bond on the other edge carbon. So where should I start numbering my carbons? And, this is a pretty good question, but the double bond always takes priority. So you always got to number it from the one that's closest to the double bond over, the one that's closest to the substituent. So you actually name it like 1, 2, 3, 4, 5. All right. You don't name it from the substituent. Double bond takes priority. All right. Remember that. So the way you would name this is, first of all, 5 carbons. That's pent, right? Think about pentagon, right? When I think about this chart right over here, I kind of think about, like, it kind of reminds me of different shapes. Like, hexagon, octagon, nonagon, 9 sides, decagon, 10 sides, right? So you could use, that, knowledge just to your advantage. So if you forget, like, oh, I have 6 carbons in a row, well, think about kind of like a 6-sided shape. What's that? That's a hexagon. What's 6? It's hex, right? So, yeah. Okay, so anyways, we have 5 carbons in a row. That's going to be pent. Because we have this double bond right over here, it's alkene, meaning that we have to put an ene at the end. And finally, we have to do our thing. So actually, even though the double bond takes priority, what you actually have to do, you actually have to put the substituent first. So I know it's weird, like you name it from the double bond, right? You name it starting from the double bond. You number it starting from the double bond, but you name it starting from the substituent. So this is going to be 5 bromo. This is going to be 5 bromo because bromine is located at carbon 5. And then this is going to be 1 pentene. Okay, this 1 tells you the location of the double bond. And because the double bond doesn't really have a substituent name, right? That's why it kind of goes before, because like bromine has a substituent name. It's just bromo, right? But double bond, it doesn't really have a substituent name. I guess you could say that ene, that kind of like makes up for it, right? That kind of gives away the fact that this right over here is a double bond. So yeah, that's pretty much it. And alkynes, you have something known as alkynes. Remember that that's when the carbon has a triple bond, and basically you name it the same way as an alkene would. So remember that if you have carbon, let's say this is triple bond, let's say this is like this, right? Let's say if it's something like this, 4 carbons in a row, that's but. And because, remember, alkanes end with ane, alkenes, they're ending with a ene in the examples in the video, and alkynes, they end with a yne. So this is going to be butene. And just like an alkene, you have to name it. You have to number it starting from the carbon that's closest to, in this case, the triple bond, right? So now you have to name the location of the triple bond as well. But it's basically the same process as what you would do with alkene, right? You have to specify the location of the triple bond, right? So you have to number it from the triple bond, from the edge carbon closest to the triple bond. Do your substituent things if you have to, but it's pretty much the same thing as before.